So we're going to keep looking at doing integrals with the exponential function at doing integrals with the exponential function here, but let's try a little problem here, some problem solving. Find the point on the graph of y equals e to the x closest to the origin. Okay? So, y equals e to the x. So we know what that looks like. Yeah, it goes to the point 0, 1. And here's y equals e to the x. So where is it closest to the origin? So what are your thoughts as we consider this one first? Okay, so we're trying, closest means the shortest distance, right? So we want to minimize the distance. Now, it's helpful to illustrate what distance we're talking about. Okay, so if we zoom in here, it says to the origin, so there's one point. And I don't want to fall into the trap of assuming it's like right on the y-axis or something. So I'm going to pick just some random point. I don't know if it's going to be to the left or the right, so I'm not going to just assume x is positive, because x might be negative, but just for the sake of our picture, I'm going to draw it like this. So that's the distance that we're trying to minimize. Okay? And of course, since that's the origin, that's the point 0, 0, what point is this up here? Okay, yeah, it's just some random point x e to the x. Okay? So that's x e to the x. So now we've got to think about our distance formula. Okay? Our distance as a function of x. Remember, this is derived from the Pythagorean theorem. If you remember where it's derived from, it's easy to remember the formula. It's the square root of something squared plus something squared. Pythagorean theorem. Right? So, what are those somethings? Well, it's it's the distance between the y's. So the y2 minus y1, e to the x minus 0. And it's the distance between the x's. So x minus 0. Okay? So, now we have our d of x equal to the square root of e to the 2x plus x squared. We simplify that. That was nice that we're hitting the origin, not some other point, because we don't have to bother foiling. Okay? So, I want to minimize this distance. At this point, we're back to a problem we've done 1,000 times. So what are we doing? Set the derivative equal to 0. Okay? So, derivative here, chain rule. 1/2 e to the 2x plus x squared to the negative 1/2 times, what's the derivative of the inside?
2e to the 2x plus 2x.
Great. 2e to the 2x plus 2x. Okay? So I'm going to simplify this a little bit here. And d prime of x. Let's see, the half I'll distribute into that second set of parentheses. That'll be nice, because that just makes it e to the 2x plus x. And that's all over the square root of e to the 2x plus x squared. Okay? Now, notice it says here, calculator active. Okay? And that's because if I'm setting this equal to 0, we're going to get a little bit stuck. Because, okay, the denominator, e to the 2x is always positive and x squared is always positive. So I know the denominator is always going to be something greater than 0. Okay, because e to a power is always greater than 0, so even if x is 0, I have some positive number that I'm square rooting, and it won't ever equal 0. Alright, so really I only have to care about the numerator, e to the 2x plus x. And like I said, we're going to get a little stuck here. If we did e to the 2x equals negative x, you know, we don't really have a good way of solving that. You know, we'd have 2x equals ln of negative x, but even that, you know, there's nothing we could really do. So this is where calculator active is helpful. Let's go ahead and grab your calculators out, graph it, and find the 0. Okay? Go ahead and plug your e to the 2x plus x in and find the 0 of that function. Alright, so we do that and we get the 0 at negative x equals negative 0.4263. So my drawing, I drew it to the right. It's actually a little bit to the left, but that is the x that would give us the closest point. So it's actually over here. So that's a negative 0.426 3 decimals.
0.653.
You did 0.653?
Yeah.
Okay. You do e to that power, 0.653 would be your y coordinate. So there's our solution. Negative 0.426, 0.653. Okay? So, some good problem solving there for us. Thanks. Okay. Alright, so let's skip down here and let's look at some definite integrals. This is the one you saw in your homework from last night a couple of times. What's the integral of e to the negative x? Yeah, negative e to the negative x, okay? And that, again, you can find using your u substitution. If u is negative x, then the du is the negative dx, and you've got to throw a negative in there. All right, so this is, we're finding the area under this curve right in here, okay? That's what we're finding. So the antiderivative is negative e to the negative x. We're going to evaluate that from 0 to 1. If we plug in a 1 first, we have a negative e to the negative 1 power. So that's negative 1 over e. And then minus we have a negative e to the 0. So that's a negative 1. Okay? E to the 0 is 1. So minus a negative 1. So that leaves us with a positive 1 minus 1 over e. And you can leave answers like that. You do not need to give a decimal. Don't waste your time, even if you do have a calculator. You can do it. Okay? Let's try another one, a little bit more complicated. We see an integral of a rational expression here. What should we automatically think of, at least? U substitution. And what pattern in particular we often look for with the rational expressions? Yeah, look for that u prime over u. So the u in this case is what? Yeah, 1 plus e to the x. So 1 plus e to the x, and the du is e to the x dx. All right, so yeah, we've got u prime over u already. Okay, what is the integral of u prime over u? ln Great. ln absolute value of u. Again, remember it doesn't matter whether you put it in terms of u or leave it in terms of x, as long as you change the bounds if you put it in terms of u. So in this case, if I did ln absolute value of the 1 plus e to the x, I can leave my bounds set at going from 0 to 1. Okay? So, that's going to give me ln of the absolute value of 1 plus e minus ln of the absolute value of 1 plus 1. Okay? Now, since I have subtraction of two logs, we can simplify this. We can also get rid of the absolute values because both of those are positive. So I have ln of 1 plus e over 2. And there's our final answer. Okay? Not too bad, right? Okay. Natural logs seem scary, but in calculus, they're really, really nice. Natural logs and exponentials are really nice to work with. Okay. All right, let's do one more here, and then I'm going to let you guys practice some. These are actually from a Barron's AP review book. But let's try one more here as practice, okay? So we have the integral from -1 to 0 of e to the x times cosine of e to the x. That's kind of a cool looking one. All right. So we got this graph going right here. We're trying to find this area. I can see it's above the x-axis, so I know it's positive. Let's go ahead and find this. How would we approach this one first? Okay. So the u would be e to the x. Okay. So du is e to the x dx. We already have it in here. Here's our e to the x dx. So that's kind of nice. So now I have the integral of cosine u du. Now I am going to go ahead and switch my bounds at this point. U is going to be e to the 0 and e to the -1. Okay? So e to the 0 is 1, so that's my upper bound. E to the -1 is just a 1 over e. Okay, so that's my lower bound. I kind of crammed this in wrong. Okay? So, what's the integral of cosine? Sine. Okay? That's sine. So, now I have sine of u evaluated from 1 over e to 1. Okay? So that's sine of 1 minus sine of 1 over e. And we can go ahead and use the calculator for this one to figure out what it equals. Don't forget you're in radians. And don't forget to put parentheses around the 1 divided by e when you do your sine. So what'd you get on that for our final answer here? 0.482. Okay. Make sure you're in radians. If you didn't get that, you might just be in degrees accidentally. Okay. But yeah, there we go. 0.482. Okay? Questions? Comments? Okay. All right. So let's go ahead and take some time here, work together, and practice with some of these. And that'll be good. Okay?